In this video, we'll start to consider pulleys. So in this example, again, I've got a hand here and a hand here. It's supposed to be two students pulling on it, but you're at home, so you can't pull on it. So what I actually have looks like this. Here we have the ceiling. There's a scale connected to the ceiling. Under the scale is a pulley. Okay? So the pulley is here. Maybe now it looks more like a pulley. So the pulley is there, and then across the pulley on one side, we'll do this side first. So on this side, there's another scale, and that is connected to the floor. On the other side is a scale, and I'm going to hang 1.5 kilograms from this side. So now my question is, if all of these start at 0, then when I add 1.5 kilograms here, what will those three scales say? This one should, since we hang 1.5 kilograms and its gravity is pulling down on it, the acceleration of gravity is 10 meters per second squared. So 10 meters per second squared times 1.5 kilograms is 15 newtons. So that scale should read 15 newtons. What about this one? Or that one? Let's find out. Alright, here's the setup. Here's the actual physical setup, and you should still be able to see the drawing of it there. So up on the top, well, let's start here. This is the place where I'm going to hang the 1.5 kilograms. You can see this one is at 0 right now. Then this loops around the pulley here and down to this one, which is connected to the floor and just balancing in place right now. So that one you can see also is at about 0 newtons right now. This one is actually already supporting things down here. So this one didn't start at 0. This one's starting at about 5. So this one starts at 5. The other two are starting at 0. Now we'll find out what happens when we add this. We expect that this one will go up to about 15 newtons. So I'm going to add these on. And let's get a closer look. So here it is now. This is the one, the masses are hanging on this one. And you can see we are expecting 15 newtons and it's around 14. So that's fine. Then it comes up, goes through the pulley. This is now the same string coming down again, past here to the one that's connected to the floor. That one also is at about 15 newtons. And that should be expected because it's the same piece of string. And we just saw everywhere in the same piece of string has the same force in it, the same tension. How about this one up here? So the one that they're hanging on, the other two went up by 15. This one is now about 35. So it used to be at 5. I added 1.5 kilograms, and now it's at 35. So when these two each went up by 15, that one went up by 30. Well, let's think about it here. So the 1.5 kg is here. This one went to 15. This is the same piece of string. So it has the same tension all the way around. This one measures the tension here. So it is also 15 newtons. This one at the top is 30 newtons. Why would that be? Let's make a free body diagram of that pulley. I'm going to make a green box to show you that my system is just that one pulley. Okay, so I want to look at what are the forces affecting this pulley. On the top, if I put my free body diagram here, there's a tension in this string. I'll call that T1. On the bottom, there are two strings coming out. So there's a force pulling down here, and this string also has tension in it. It always pulls. Tension always pulls. So there's a force pulling here and a force pulling here. And we know they're the same string, so it's the same tension. I have two T2s and one T1. All right? The tension in each of these strings is 15 newtons. So I know this is 15, that is 15. We saw that it wasn't moving, so it's in equilibrium. Since it's in equilibrium, if there are 15 plus 15, that's 30 newtons pointing down, there have to be 30 newtons pointing up. So T1 has to be twice as large as T2.